By the end of this lesson, students will be able to relate the differences in electronegativity with the formation of ionic and covalent bonds. Identify the polar and nonpolar bonds in molecules. Determine whether a molecule is polar or nonpolar from its geometry. Understand the ionic properties in covalent molecules. Understand the existence of covalent character in ionic bonds. When two atoms form a covalent bond, a pair of electrons in the bond is shared between the two atoms. Click the CL button to view the formation of a CL bond. Now, click the HCl button to view the formation of an HCl bond. What can you say about the sharing of bonding electrons from their position in these two molecules? Click Next for the answer. Answer: the sharing of bonding electrons is equal in the CL bond but not in the HCl bond. The sharing of electrons will not be equal if the bond is formed between atoms of different elements. This is because different elements have different abilities to attract electrons. The ability of an atom in a covalent bond to attract the bonding electrons is called electronegativity. Atoms whose valence electrons experience a large effective nuclear charge are highly electronegative. Click on the electronic structure checkbox one by one to view the electronic structure of period 2 elements. Click the proton number checkbox. The nuclear charges of the elements of period 2 are shown. Now, deduce the change in electronegativity of the elements across a period. Click the electronegativity value checkbox to check the answer. Answer: electronegativity increases from left to right across the period as a result of an increase in the effective nuclear charge. Click on the electronic structure checkbox one by one to view the electronic structure of group 1 elements. Click on the proton number checkbox. The nuclear charge of the elements of group 1 are shown. Now, deduce the change in electronegativity of the elements down a group. Click the electronegativity value checkbox to view the answer. Answer: electronegativity decreases down a group as a result of a decrease in effective nuclear charge. The electronegativity values assigned to each element are shown in the periodic table above. What type of elements are highly electronegative? Click Next for the answer. Answer: nonmetallic elements at the top right corner of the periodic table are highly electronegative. The sharing of electrons will not be equal if the bond is formed between atoms of different elements. This is because different elements have different abilities to attract electrons. The ability of an atom in a covalent bond to attract the bonding electrons is called electronegativity. Electronegativity increases from left to right across a period. Electronegativity decreases down a group. Let us look at the HCl molecule again. The unequal attraction for the bonding electrons in HCl results in an unbalanced distribution of electron density within the bond. The hydrogen end of the molecule now acquires a slight positive charge as a result of the shift in the electron density. This results in the covalent bond carrying partial positive and negative charges at opposite ends. We use the symbol delta to denote the partial charges. The bond is called a polar bond. Because there are two poles of opposite charges involved, the bond is said to be a dipole. We normally use a crossed arrow above the bond to indicate the direction of the shift of electrons. The head of the arrow points towards the negative end of the dipole. Let us look at some other covalent bonds. Which bond is the most polar and which is the least polar? Click the sort button to arrange the bonds in order of their polarity. What can you deduce about the degree of polarity of a covalent bond based on the information given in the table? Click Next for the answer. Answer: the degree to which a covalent bond is polar depends on the difference in electronegativity values delta En. The greater the difference in the electronegativity, the more polar is the bond. A polar bond is a covalent bond carrying partial positive and negative charges at opposite ends. The greater the difference in electronegativity values between the elements in the bond, the more polar is the bond.